Water is the most vital resource that we have, but it is not a given that we will continue to have a safe supply of it. Droughts are coming, the likes of which we haven't seen before. We need technology that can produce safe water for years during these periods, lest we find ourselves without water, fighting to survive like some sci-fi movie. But the solution can't be expensive, and on large scales, these solutions are expensive. But there is a new hope, a new technology that may just save us from this future, and all while producing safe drinking water cheaper than tap water. Let's discuss this new scientific breakthrough. There is a looming omnipresent threat of climate change-induced droughts that are longer and more severe than ever. Growing up in Australia, I know all too well how bad droughts can get. At one point, the water in our reservoirs was so low that they had to increase the amount of chlorine in the water dramatically, which resulted in the water changing viscosity. It was thicker, slimy, smelt, not the most pleasant thing to drink. It's shocking when this kind of drought affects wealthy countries, but many poorer nations have constant issues with water resources. Building extremely expensive desalination plants to pull water from the ocean is simply not viable for these countries. Even wealthy countries will avoid it if possible. But if desalination is so good, why isn't everyone building them around the world? Like most limitations in the world, it comes down to money. Desalination is traditionally an expensive and energy-hungry process. This is because desalination is intrinsically a hard problem. Osmosis is the tendency of water and other liquids to distribute themselves so that any solutes, which in this case is salt, will have an even distribution. The traditional way we think about this is if we had a membrane with salt water on one side and clean water on the other, the clean water moves to the saltwater side to dilute the salt concentration. Now, this is the exact opposite of what we want to achieve with desalination. It is acting against us trying to remove salt from the water to make it safe to drink. But this can be overcome, and there are many different techniques to do this. Most, but not all, fall into two categories: distillation and reverse osmosis. The most common for desalination plants is reverse osmosis, mainly because it's proven to be effectively scaled up to produce large volumes of water. Once again, there are multiple ways to implement this, but a common method combines a semi-permeable membrane with high pressure water to separate the salt using brute force. Basically, it uses the combination of heat and pressure to force the water through the membrane, leaving the salt behind, which is then pumped back into the ocean. The problem with this approach is the energy required. You have to pump the water from the ocean to the plant. Then you have to put it under high pressure to force it through the membrane. Then you need to pump all the salt back into the ocean far enough away from the coast so that it doesn't make a hyper-rich salt region, which would kill the local wildlife. So it is expensive and it's energy hungry. The other method of distillation dates back centuries. Sailors stuck out at sea for weeks on end could produce fresh water from this method. It simply involves the heating of water until it evaporates, then capturing the water vapor and letting it cool back down and condense into fresh, clean water. In chemistry, you'll find some really cool glassware for performing this task well, as it is used to capture toxic and deadly vapors rather than water. But even rudimentary methods can work with this. Even Aristotle wrote about performing this exact experiment way back in around 350 BCE, when he wrote, "I have proved by experiment that salt water evaporated forms fresh, and the vapor does not, when it condenses, condense into salt water again." So if Aristotle could do it, why aren't we using this method now? Generally, it requires more energy to boil the water than it does in the reverse osmosis technique. But this new developed device is different. It is cheap and it doesn't use electricity. That is because it just uses thermal heating from the sun to passively evaporate the water and collect it. But surely this has been done before in the past, I hear you ask. And you are right, it has. But there is an interesting design feature about this new device that makes it special. And it is all to do with waste. After evaporating water, a slurry remains with a very high concentration of salt. The problem with previous designs is that this salt would build up and eventually clog the device. This would mean expensive, regular repairs and would limit scaling this technique. To avoid this, the researchers placed the entire device on a slope. The higher concentration salt water is heavier and will tend to move down. So by having a slope, the salt can move out of the device and be replaced by new, low salt concentration water. This avoids having components that will clog, and the great thing about this design is that it's simple, which means there are a lot fewer things that could go wrong. The researchers estimate that if this system was scaled up to the size of a small suitcase, it could produce about 4 to 6 litres of drinking water per hour and last several years before requiring any replacement parts. This would produce water cheaper than tap water, which makes this an extremely viable method. But it still has problems that it needs to overcome. For starters, it needs to be scaled up. At the moment, it is a pretty simple design, but it is also being tested in a controlled environment. It is not deployed in the ocean. The device is more suitable for calm, controlled saltwater baths and will need to be changed to work in the sea. But as always, this is ongoing research, and I am sure that the researchers are working hard to realize this technology in a scaled up way and deploy it in the real world. This could make significant difference to remote, poor communities around the globe, and it will be exciting to see how they develop this further. Developing new technology is hard. It requires an understanding of many different aspects, like programming, mechanical and electrical engineering, and a good basis in the scientific method. It can sometimes be hard to start the learning process on all these topics, and that is where the sponsor of this video, Brilliant, comes in handy. Brilliant is an interactive online platform that offers many courses that can teach you the fundamentals behind inventing new technologies. For example, this course about learning how technology works from zero knowledge. Learning can be boring and tedious, but interactive learning, like what Brilliant offers, makes a big difference. You can get started for free for 30 days, and the first 200 people to sign up using the link brilliant.org/sciencediscussed will get a further 20% off. It is exciting to see new research that is developing practical devices that have the potential to change the lives of many people. Artificial intelligence is also rapidly changing our lives. We are at the stage now where scientists are trying to use AI to decode the language of whales. But to learn more about this, you'll have to watch this video.